Okay, Algebra 2 students, here's the first video for section 6.6, exponential and logarithmic equations. How do the properties of exponents and logarithms help you solve problems? In the end, you're going to be able to solve exponential and logarithmic equations. Moving ahead to example 1. Oh, before we do, suppose b is greater than 0 and b does not equal 1. Then b to the x equals b to the y if and only if x equal y. Yeah, so if you have the same base, then x will equal y. If two powers have the same base, then their exponents are equal. Yep, so it seems like that's going to come into play. Solve exponential equations using a common base. All right, so it doesn't look like they have the same base, but they can be written with the same base because this has 2 as a base. That's 2 to the negative 1. When you see a fraction, think about negative exponents. That's 2 to the negative 1. And 4 can be written as 2 squared. So that's going to show up right off at the beginning of the problem. Oh, good. It's one of the slide ones. I like it when they use the slide one so I can walk you through it. So I already mentioned that 2 can be negative 1. 1/2 can be written as 2 to the negative 1. And 4 can be written as 2 squared. Okay. Now you have a power to a power, so you can distribute the negative 1 to the x plus 7, and you're going to multiply the 2 times the 3x to get 6x. Okay, distribute the negative 1 times x and negative 1 times 7. So now you have 2 to this power equals 2 to this power. Or let me word it this way. 2 to this power equals 2 to that power. Since they're both 2 as the base, that means this equals that. And then you can solve this equation for x. Add x to both sides, divide by 7, and get x negative 1. Okay? And when you get that, yeah, we're trying to solve for x. There we go. So you may need some practice on finding what the base is. So look at these numbers, the bases, and say, okay, what do they have in common? What's the common base between those two? Rewrite them, then distribute, and go for it. How about this? What if you have a small number like that? What does that mean? Well, it's probably got the same base as this, or else they wouldn't give it to us. Give these a shot and come on back when you're ready. These both have 5 as a base. 5 squared and 5 to the third. Now, I also have 3x, so I have to multiply the 2 times 3x, and I have to multiply this 3 times x plus 2. Okay, so I still have 5 as a base. 2 times power to a power, you multiply and get 6x. Here's a base of 5. It's 3, but then I also have to raise it to the x plus 2, so I'm going to distribute 3x plus 6. Now we have the same bases. That means the exponents have to be the same. 6x must equal 3x plus 6. Solve that for x. Subtract 3x from both sides. Divide both sides by 3 and get x is 2. Okay? How about the other one? They have to have 10 as the base, right? That has to have you can write that as 10 to a certain power. Whenever it's a number smaller than 1, think about negative exponents. 10 to the negative 1 would be 0.1. 10 to the negative 2 is 0.01. 10 to the negative 3 is 0.001. If you don't believe it, here we go. 10 to the negative. Whenever you have negative numbers as exponents, makes it like a fraction, 0.01. This equals 10 to the 6x. So since they both have base 10, negative 3 equals 6x. And if negative 3 equals 6x, you can divide both sides by 6 and get that x equals negative 3 over 6. Negative 3 over 6 reduces to negative 1/2. Sorry I didn't show my work. Trying to cut down on the video length. Let's make sure those two numbers are right. I got negative 1/2 and 2. Negative 1/2 and 2. Negative 1/2 and 2. 2. Negative 1/2. You can do problems 16 through 21 and 45. That's it for this video. Have a great day.